Good evening, and welcome to the fourth and final session of Starting the Season Safely on Specialty Crop Farms. My name is Christine Lang, and I'm an SDSU Extension Consumer Horticulture Specialist based in Brookings, South Dakota. And thank you for joining us live, or for folks who are watching the recording. We appreciate you finding us and checking out this series to train yourself and potentially some of your farm workers or community garden volunteers in keeping yourself and everyone else around you safe on your farm or in your community garden settings. Tonight's topic is one that I'm especially excited about. I'll share that I have enjoyed all of the topics and I've learned new things from all of my colleagues and our speakers. But I think tonight's extra special because we have a guest speaker joining us from the University of Minnesota. So tonight we're going to be hearing from Laura Edwards, our SDSU State Climatologist. And we're also going to be hearing from Kent Boyd, who is a registered nurse and University of Minnesota Doctor of Nursing Practice student. So both of them are joining us via Zoom. And we're going to have a two-part session focused on extreme heat projections and protections. So tonight we're going to be learning what is in store for the season and how to protect yourself and your employees on the farm. And so first up tonight is going to be Laura Edwards. And Laura was appointed as the SDSU Extension State Climatologist in January of 2017. She's based in the Aberdeen Regional Extension Center. And before she began as state climatologist, she had been the SDSU Extension Climate Field Specialist from 2011 to 2017. Her previous experience includes having been a research climatologist at the Western Regional Climate Center in Reno, Nevada. So again, Laura understands heat. And she has also been the assistant state climatologist in Maryland. She holds a master's degree in meteorology from the University of Maryland and a bachelor's degree in physics and French from the University of Minnesota. Laura, I will not be asking you any questions in French tonight. I will not be able to do that. If anyone has questions during Laura's presentation, please drop those in the Q&A. And after she has concluded her formal presentation, we'll get into Q&A and discussion. And then we'll be passing the microphone to Ken. So Laura, welcome and take it away.
All right. Thank you, Christine, for that introduction. And I'm glad to be with you all today. So here, I know the title of the whole seminar, the webinar today, is Extreme Heat Projections and Protection or Preparedness. And so, but I'm just going to talk about the projections part. So I just kept that part for my title slide here. And so I'll talk about a couple different perspectives. First, kind of the weather part of it, when you're looking at short-term, weather forecasts, those kinds of things, but also thinking of extreme heat in more of a climate sense and a climate perspective. So I'll kind of try to bridge the two of those here between both weather and climate when we're talking about extreme heat. So first of all, since I'm kind of the first speaker here, I didn't mean to steal any of Kent's thunder if he has some of this kind of stuff, but just thinking of what are the hazards of heat when we're talking about why this is important. And first of all, using information from the National Weather Service, heat waves kill more people in the country than all other weather-related disasters combined. That includes lightning strikes, floods, hurricanes, tornadoes, severe weather, winter storms, all of that. The 10-year average, a recent 10-year average from 2013 to 22 for heat-related deaths in the U.S. was 153 in a typical year. That's from the National Weather Service. Now, how this happens kind of relates to, really relates to the environment and how your body responds. And so when I'm thinking as an atmospheric scientist or a meteorologist on this, they go, what's the environmental conditions that lead to heat stress or death? And so that's the second bullet there. It gets to when air temperatures are below the body temperature, your body can stay cooler, and it can move heat away from your body more effectively when you have cooler air around you than your body temperature. But when your air temperature reaches about 95 degrees or something close to your natural body temperature, you don't lose that heat as effectively. And also the humidity part plays a role. So when you have high humidity, that slows the evaporation, how quickly, water droplets turn to water vapor, and prevents um, this, the really important ways of how your bodies cool themselves. So it's hard to cool yourself down when you have high heat and high humidity. You can't lose that heat as effectively. So thinking of kind of the physics of it, the science of it, sweat is evaporated, so it changes from liquid to gas when you add heat. And in the case of your body in a high heat situation, high humidity situation, that heat is supplied by your body. So you're generating heat to evaporate more, and that evaporation is not happening as effectively when you have these high heat, high humidity kind of environment conditions. So these are kind of two ways of looking at it. If the air is unsaturated or relatively dry, there's more room for water to evaporate into your surroundings, into the environment. But if the air is saturated, or in the case of higher humidity, you can't really add more liquid, more water to the surrounding air. And so that heat remains in your body because your body is still trying to generate heat to evaporate that water that's not working very well. So that's when you get to that heat stress and heat issues with your body. So part of this, so this kind of information has gone into NOAA, National Oceanic and Atmospheric Administration, and the National Weather Service, and how they define heat index. And so this is a chart that looks at temperature versus humidity. So temperature across the top and humidity down the left-hand side. And you can intersect those looking at air temperature and compared with what percent of relative humidity. And then they have different categories here of caution, extreme caution, danger, extreme danger. So, the darker the orange or the red, obviously the worse, the higher heat index and the higher risk that you have. I want to say here that heat index is the same as apparent temperature. So if you hear those words, those two are interchangeable, heat index and apparent temperature. But I would like to say that heat index is not the same as feels like temperature. Like there are a number of weather apps out there, right? That will show different ways of explaining extreme heat, well, extreme cold too, but extreme heat. And one of the things that I've seen a lot is this feels like index or feels like temperature, which is something similar to this, but not the same. So that tends to be something kind of proprietary, that they've come up with as kind of a replacement or maybe a marketing way to describe extreme heat. So just so you know that they may not be the same depending what weather source you're using. I really like the National Weather Service because a lot of it has been founded in science and research over many, many years that they've developed these heat index charts, for example. So heat index and apparent temperature are the same. And here's their chart, which you can find on their website. They have it a lot of different places. To get a little bit deeper into the National Weather Service and how they describe anticipated high heat, high humidity events, I went to some of their resources as far as their guidance for the forecasters and what their criteria are for different headlines. And so there's a few different things here. I have another slide that continues here. But first of all, early on, if they anticipate a very high heat, high humidity event, and this is true for any severe weather or high impact type of weather, they'll put out something they call a hazardous weather outlook. And the color that you see on the screen here is the color of the warning. So when you see a hazardous weather outlook in kind of this like orangey beige color, however it looks to you, that is typically a heads up, sometimes as much as a couple days, in advance, that they're anticipating a high impact event. And so they'll put a hazardous weather outlook out for excessive heat if they see this coming down the forecast, in the next week or so. And for this criteria, they look at a period of excessive heat that's possible within the next 3 to 5 days. And it may lead to stepping up and getting either a heat advisory or an excessive heat warning, but they usually don't issue the advisory or warning until they're a little bit closer and they have higher confidence of what the actual forecast is going to be. So typically, again, like I said, it's kind of a heads up to start preparing, get yourself ready, and looking out for those that you care for, if anything like that. The next step oftentimes is issuing a heat advisory, and this is where they want you to start taking action, and that they're actually expecting some kind of excessive heat event, usually a combination of high temperatures and high humidity that can be hazardous. Okay, so for the National Weather Service in the 3 South Dakota offices, so Rapid City, Aberdeen, Sioux Falls, if you're in any of their forecast regions, they issue the heat advisory when the heat index is 100 degrees Fahrenheit or higher, and that's what they anticipate. Okay, so that is a heat advisory. So it's kind of like the first level of heat warnings. Kind of another, so it's kind of, think of it as like a severe thunderstorm warning. And now we're looking at like tornado watch, tornado warning, only we're looking at excessive heat. So kind of the next level severity, at least, might not always happen in this order, but next level severity is likely excessive heat watch. So then this again is a preparedness statement, that they are expecting a period of over 48 hours consecutive of excessive heat. And so again, they'll issue this usually, as soon as advanced as they can, maybe a day or so, when they see all the right ingredients basically coming together for an excessive heat event. Now, the next level then is the excessive heat warning. So if you remember way back, the heat advisory was 100 degrees Fahrenheit heat index or higher. For the excessive heat warning for South Dakota, all the areas of South Dakota, it's 105 degree heat index or higher, plus minimum heat index, so say the overnight heat index of at least 75 degrees. So this implies that you have high heat during the day and high heat humidity during the day and high heat humidity overnight as well. So these numbers can be fudged a little bit. The official guidance gives them, at the local office where they issue the forecast, they give them a couple degrees wiggle room, one way or the other. So if you can have 105 during the day, and here in South Dakota, you can have like 70 the same night. But still, if you have that continued over a couple, consecutive days, they may still issue a heat warning, for example. So these are the guidance at least, but they may fudge the numbers if they see really a prolonged high heat, high humidity event is really the message they want to say here. Okay, so we have the heat advisory, the excessive heat watch, and the excessive heat warning, with the warning really being that criteria over 48 hours of elevated heat and humidity. So like I said, they have some leniency in their criteria. One thing to note too, if they have that advisory criteria, so the 100 degree heat index, if they see that persisting for 4 days or more, they may issue an excessive heat warning, even though it doesn't meet that 105 degree heat index threshold. So if you see this, if you or your employees or whoever's working for you, and you see this kind of information in the weather forecast, certainly this is the point where you take action and start thinking about what are some alternatives, different times of day, maybe working earlier morning, in cooler parts of the day, those kinds of things, if you still have to get some field work done. An example of when you might not see a heat advisory So I was visiting with the National Weather Service earlier today about this. For example, a few Saturdays ago, we had 89 degrees in Aberdeen, really warm, right? Really warm for April, right? And that popped up and flagged some of their forecast tools and say, hey, this looks like high heat because it is unusual, really unusual for this time of year. And certainly that was like a record or near record high temperature for most of the region that day. But they're not going to issue a heat warning in that case because it's one single day that bumped up, in the 80s, and it wasn't prolonged. It didn't last very long. So, most people can adapt to a one-day, spike in temperature. So that's an example when they would not issue a heat advisory, but certainly it's warmer than typical. Another thing to consider too is thinking of acclimation periods. So, and comparing to kind of climatology historically, where, when we're later into the summer, in late June or July, our bodies have acclimated a little more to the warmer temperatures. And so that's where you see those 100, 105 days, maybe having a higher impact, where in April, you're not quite acclimated to even maybe 80 degrees. So there is something of seasonality in there that they consider, but again, their official criteria are 100 or 105. I looked around the country today. I was trying to get a screenshot of what the actual watches and warnings look like on a heat warning. There's nowhere in the country today that is having a high heat or humidity event. So I took a snapshot of an area that has severe weather today because it did have multiple hazards on the weather forecast website today. So this is a snapshot from southern Iowa that's having some severe weather today. And this is what they'll have: the current conditions up top here, but then they'll have multiple hazards. They'll have a flash flood warning, a flood watch, and they have this eye for more information, to click here for more details. So that can help guide you as to what the hazards are. Similar at the top, kind of above the current conditions, kind of near the top of the screen, is the hazardous weather conditions, and that too outlines what are the outlooks, watches, warnings, advisories, whatever's in effect for that location from the National Weather Service. And I just pulled this from weather.gov, is the National Weather Service website. So you can look at weather anywhere in the country there. Just click on the map and click down to your local area, and I'll give you this weather forecast. If you want more detailed information as far as, gosh, when is this high heat, high humidity really going to be in effect, you can click to this hourly weather forecast, and it gives you basically an hour by hour graph. And you click a humidity, temperature, wind, all of that stuff hour by hour, so you can maybe plan even more precisely when might be good times to go out and work. A new experimental thing, and I'm just sharing this because it's experimental, but it's kind of cool. It's a new collaboration with the National Weather Service and CDC, and Centers for Disease Control, and they're looking at heat risk. I have the link down at the last, kind of the end, where I have some resources listed because it's kind of a funny long URL right now. But you can look at maps of these different color-coded risks. They're not using this for official forecasts, but it's a tool in their toolbox as far as, helping advise like what might be coming down the pike. And this is really looking at climatology, like how unusual is this upcoming heat event as compared to historical conditions for this place and at this time. And so you have the map of the country here, and on the left, you can click ahead, out to 6-7 days out to look at, what are the heat risks day by day anywhere in the country. And this is what it looked like today. So really pretty minor heat events, if anywhere, today. One other thing that is becoming more used when you're looking at human health is this thing we call wet bulb globe temperature. And so this is a little more difficult to measure, but what's really good about it as far as human health goes is that it accounts for temperature and humidity, but also radiant heat, or what we call how exposed to sunlight are you, and wind speed, because all of those can work different ways to make things worse or make things better as far as heating and cooling ability. To go back to heat index, that is measured with a thermometer in the shade, usually a ventilated thermometer in the shade. Where here, wet bulb globe temperature, you can take the temperature out in exposed sunlight, which is actually preferred if that is where you're working, actually. And so this is an example, a little sketch on the right here of what an example measurement instrument might be that you could take out in the field, and you can buy little handheld versions of them too. But you have kind of three ways, three measurement devices here. You have a wet bulb that has something like a little damp sock over it, damp cloth. And as the water evaporates from that, evaporation cools the thermometer. And so this is kind of mimicking how human body cools itself. The black bulb or the black globe is emulating a dark surface for that solar radiation component. And then the dry bulb is basically the air temperature that you and I kind of are already familiar with. Although this would be measured in the sunlight if you want. So it's kind of another way to look at what the heat stress might be here. I'll share you some data or some information from the South Dakota Mesonet, our weather station network in South Dakota. At the moment, we're not calculating this variable, but it's something we've thought about. They use it quite a lot in the southeastern states, for example, at football stadiums, not just for the football players, but also the people that are in the stands, all the attendees. If they have a very high wet bulb globe temperature, they'll stop or defer play, reschedule, those kinds of things, because of the human health risk. And so you can find more information on this online too, on what different thresholds might be. I think I forgot to put some of that in here. So looking at climate perspective, long term, we're seeing temperature trends that are rising, and we see different seasonality. Winters are warming faster than summers, but we also see increases in overnight temperatures faster than the daytime high. So the daytime high is probably what's more of concern to you, but thinking of overnight temperatures too, we can still have some high humidity and warm nights. And we're seeing increases in the number of warm overnights in our part of the country. Some new information that came out from the National Climate Assessment that was released in November of last year shows that nationally, at least, they're expecting increases in farm worker exposure to extreme heat and smoke to basically double by mid-century, so in about 20 to 30 years from now. And that is in Chapter 11, the agriculture section, where they kind of talk about that. It's kind of split over a few different chapters of the report, but they really mention it in the agriculture part, because this is really something that we're thinking about. A couple summers we've had a fair bit of smoke come in from Canada, the western states, here in South Dakota as well. So it's not just the excessive heat, but also smoke that can exacerbate or make worse some of those health impacts. And just a couple reasons, or a couple graphs here from that National Climate Assessment Report, kind of illustrating why excessive heat or extreme temperature can be a factor just in the general food supply. This is thinking of just local foods, but also, bigger agriculture production. Where extreme temperature is one of the big factors that they look at. Worker health and safety certainly is a issue, but also quality of your produce and your ability to work and harvest at the right time or do other work, and keeping the quality of food as it goes through the food chain or the food supply chain. Thinking of climate change, we're looking at increases in the future of some high heat events. And that is the very first thing that they talk about. Maybe the unavailability of food is a supply barrier with high heat or smoke events that could kind of break a link in the supply chain. So they're looking at this in a climate change perspective as well, not just looking at the weather part of it on the day-to-day operations. And I just want to throw one other thing in here before I get to the outlook part for the season, that the South Dakota Mesonet, we don't have a lot on the human health side, but we do have a little bit on livestock health. And so I know some of you might have small animals or maybe larger animals on your farm. We have this livestock stress tool that is updated all the time, all year round, both for extreme heat and extreme cold events. And we look at this comprehensive climate index, or CCI, of which is different criteria for newborn or adult animals. And so if you're working on the farm, not just thinking of human health, as we're talking about mostly today, but also thinking of livestock health in some of these extreme conditions, we use that CCI, but we also show heat index and the temperature humidity index under these high heat events. You can see it as a map, looking at all the stations, what areas might be more at risk than others. And you can also look at individual stations. This is just an example from Gettysburg today. You see the left lines are historically of the last couple of days, what the conditions have been. And then the dotted line moving forward is the forecast, the weather forecast on where that climate index might be going. So you can kind of anticipate ahead of time what might be some extreme times, either in heat or cold conditions. So just looking out short term ahead, we don't see any high heat events coming in the first couple of weeks of May here. In fact, cooler than average temperatures are expected, and kind of typical to maybe slightly wetter weather precipitation conditions in the first couple of weeks of May. So not seeing anything really extreme heat coming down in early May. And as you look at May overall, similar kind of thing. We don't really see extreme heat being a factor here in the month of May. In fact, temperatures are kind of uncertain as it looks to kind of flip towards a colder pattern in the middle to latter part of the month. So that might kind of erase any of the warmer days that we might have here early in May. And then on precipitation side, again, slightly leaning towards wetter in the northeastern part of the state, but not really high confidence in that. When we look out further ahead, though, I think is where we have a little more concern. May through July, we see kind of this transition time. Again, May is starting to look like a little cooler. Precipitation, kind of a toss-up here as you look at May through July, kind of the first half of the growing season. That's not to say we can't have some high heat events, intermittently or occasionally, but it doesn't look like persistent warm temperatures are really very likely in the next 3 months. But I want to say when we look at latter part of the summer, so July through September, we start to see higher confidence of warmer and drier conditions coming across the region, really from Canada all the way down to Texas. This is kind of going out on a limb for the Climate Prediction Center to say something so bold with precipitation especially. But I want to say, Christine said I came from Reno as my last position, and you can still have heat stress, heat mortality, heat morbidity, even in dry heat if it's prolonged at all. And so just want to say a word of caution, even though it looks like drier plus warmth, you're like, oh, well, that's not so bad. Still, if it's a prolonged event, that still can have some health impacts for you and your workers out in the field. So keep an eye on that as we get through the summer. So with that, I have a few resources, and certainly I can share this PowerPoint with anybody who's interested, who wants the links or the graphics. It's all public domain, and I thank you for the time, and I'll take a few questions if there are any.
All right. I'll remind folks that Laura's going to have to depart. She's got some fun family things going on for the rest of the evening after this. So if you have any questions, this would be a great time to ask. And for recording purposes, you can certainly see Laura's contact information on the slide right now. But again, you can always find her profile and cool resources and articles that she's written on the SDSU Extension website as well. And Laura, I appreciate learning about the wet bulb globe index, and I might have said that out of order, I realize, but that's something I didn't know about. So I'm going to be thinking about that a little bit more in terms of my team and that metric. And I am really excited about the National Weather Service heat risk tool. So I will be keeping an eye out for that as well.
Okay, sounds great.
Well, I'm not seeing any questions at this time. As always, Laura, you get tasked with being the bearer of some kind of dreary news, so to speak, but it's always sets the stage for, okay, and what are we going to do about it? So we wouldn't get to the and what are we going to do about it part if it wasn't for you. So thank you so much, Laura. And we're going to be transitioning to having Kent up as our next speaker. And again, Kent's joining us from the University of Minnesota, and he is part of a larger team at the University of Minnesota that is focused on climate adaptation. And I apologize, Kent, I totally closed your bio and I'm opening it back up. Again, Kent is a registered nurse and Doctor of Nursing Practice student in the Health Innovation and Leadership Program at the University of Minnesota. And he is focusing his studies on planetary health, which I didn't know what that was until I read the rest of this. So he's particularly interested in food systems, community empowerment, adaptation and resilience, and transformative systems change. So a very nice complement to everything we just learned from Laura. Kent recently partnered with the Minnesota Climate Adaptation Partnership to create a first-of-its-kind training program that positions health professionals as champions for climate resilience strategies across Minnesota. And I can share that I have personally already been in the audience when Kent has presented some of the resources that have come out of his collaborations with the University of Minnesota Extension team. And I am thrilled to have you here tonight, Kent. So take it away.
Thank you so much, Christine, for that introduction. And I'm just getting everything set up here. Sorry about the share. We'll do this. Okay, we should be good.
Looks great.
Okay. So again, thank you, Christine, for having me here. I do come from the Northeast in Minnesota. And I know I'm a bit of the oddball being a nurse, talking to farmers and talking about climate change and extreme heat projections and air pollution as well. But as Laura introduced, it is important for human health. And I think she did a great introduction to some of the tools that are available, as well as those projections and what some of the language means when we get these notifications on our phone and we're looking at weather apps and such. So I appreciate her going before me as well. And we will get started here. So as our climate and environment projected to change, we know some of the impacts that this can have on human health. Extreme heat, air pollution, increased infectious diseases, longer growing seasons and allergens, water quality, all of these have direct effects on human health. And you can see that here. For example, we're talking about extreme heat. So with prolonged extreme heat events, again, what Laura was describing, some of those direct impacts include heat illnesses, exacerbations of comorbidities like respiratory disease, cardiovascular disease, diabetes, and kidney disease, which can ultimately lead to death if untreated or not treated in a timely manner. However, it's also important to look at the big picture and look at those indirect impacts of extreme heat in this example. So things like increased ambulance callouts and slower response times from EMS. And this is already an issue with a lot of rural farmers not having that accessibility to healthcare services. There's also a likelihood of having increased number of hospital admissions as well as fuller emergency departments. Storage of medicines, a lot of medicines need refrigeration. This isn't always possible during extreme heat or complicated as you're out in the field and need that medication. And it's also been shown that some medications, so for instance, asthma inhalers, are less effective in extreme heat conditions. There's also increased risks of accidents, we talked about transmission of infectious diseases and those vector-borne diseases. They like heat. Their habitats are usually those hotter environments. So their migration patterns are changing, their habitats are changing, and they're kind of creeping up more into these northern environments where they haven't been seen before or seldom so. And then also we look at the infrastructure concerns. So we have power outages, again, water quality and treatment, and then productivity out on the farm. So as Laura mentioned, extreme heat is the highest U.S. weather-related killer. Now, her numbers were slightly smaller than mine, and that gets into an interesting point that I was going to make. So the EPA estimates that about 1,300 deaths annually per year are because of or contributed by extreme heat. Now, her numbers, these numbers, there's likely underreported, or they're likely underreported and underrepresented because of the way that a medical examiner would attribute heat to a death certificate, right? So it could be a cardiovascular event that ends up being the mortality of a person, and whether that's attributed to the extreme heat event or not is really up to the discretion of the provider. So there is likely underreporting of these numbers. Another reason why excessive heat is so important to address, but also such an important, worrisome event, is because some of the risks with extreme heat, so we're talking about heat illnesses, they each look similar. They all build upon each other depending on exposure to the heat, and they have similar symptoms. I can't remember if I said that or not. The good thing is, though, is that they have similar treatments. A lot of them include water, rest, shade, having some nutrients of some sort, and then also just awareness and addressing the issue. So whether that's contacting your supervisor or contacting emergency services. So they build on each other. There are two, though, that are especially important to cover, and that is heat exhaustion and heat stroke. And we'll look at both next. So in terms of heat exhaustion, some of the signs and symptoms that are different from heat stroke include a feeling of faint, tired, dizzy, sweating, which is important, and this feeling of thirst, cool, clammy skin, a rapid but weak pulse. Nausea and vomiting kind of goes with both, and then muscle cramps are different than what you would see with heat stroke. And some of these treatments include stopping all activity and resting, like I said before, loosening clothes, applying cool cloths, or immersing in a cool bath. It's also an important time to offer this person drinks of water or sports drink if available. But there's not necessarily any medical action unless this continues for a prolonged period of time, so over an hour. With heat stroke, it's different, both in symptoms and in treatment. So we have throbbing headache, confusion, the skin will be hot, red, dry, or damp, as opposed to the cool and clammy, and body temperature will be 103 degrees Fahrenheit or higher. That pulse is going to be rapid and strong. And then likely, if not immediately upon noticing these symptoms, shortly after, there's an increased chance of loss of consciousness and fainting. So if you notice heat stroke, and I said this once before, and I was like, if you notice it in yourself, but likely at this point you won't, because you're going to be confused. You're going to have all these other things going on. So we'll get to some of the actions that a workplace can take on a farm. But if you notice this in someone, this is a life-threatening event. Call 911, get that person out of the sun into shade. Best case scenario is to immerse them in some sort of cool bath. But if that's not possible, cool cloth, again, loosening the clothes, making sure that their feet are elevated above their chest, above their heart, to return some of that blood flow back to the system. And don't give these individuals any fluids. The reason that this is a medical emergency, so heat stroke, that temperature of 103 degrees Fahrenheit, if that's not caught within 15 minutes, the body temperature can increase to 106 degrees Fahrenheit. And that's when you start to see organ failure. So at that point, it's, again, a medical emergency, and it can lead to death rather quickly. Another reason that extreme heat is important, especially for farmers and people that work outdoors, is because of the risk factors for heat illness. So I'm not going to read through these, but I want you to just look at them and see how many of these are attributable to you as a farmer. I can see 4, arguably 5 right away. But think of yourself as an individual or those that you work with. How many of these are prevalent with your workforce? And as I let you look at that, I also wanted to highlight that the most vulnerable populations for extreme heat and other weather-related disasters and illnesses are those with pre-existing conditions, the elderly, women, children, migrant workers, as well as people of color. And it's also been shown or studied from the EPA. So since 1999, people aged 65 plus have been several times more likely to die from heat-related cardiovascular disease than the general population. And I just read an article today, although it was from February, that South Dakota, they just recently published the farmer age data that showed 2/3 of farmer population is at least 55 years old, if not older. And then again, linking back to what Laura said, it's projected that double the heat and air pollution days in the next 20 to 30 years. So if we're looking at those that are aged 55 years or older, by the time that this is projected to get worse, they're going to be in that age range. So now to look at some of the what can we do's, right? And the not most important, but one of the most important areas of prevention is hydration and protection. So there have been some studies that have shown that outdoor workers and manual labor workers start off the day about 40 to 70%, 40 to 70% of those workers are dehydrated. Now I know that's kind of a wide-ranging percentage, but it does just go to show how important hydration is before work. And also looking at those beverages that we drink in the morning. I'm a coffee drinker. If I'm doing that before going outside in extreme heat events, I'm setting myself up behind the curve. I'm failing myself, and I'll need to drink more water to catch up. So that's the other part of it, is drinking that cool water with a snack. If not, you can add in some electrolytes, but that's used sparingly. I know there's a lot of conversation about how good it is for you, but in terms of extreme heat, and like Laura was talking about with stress, you can actually overdo it. So the best option is water. Avoid things with sugar, with high caffeine, and of course, avoid alcohol. it's recommended that you drink 8 ounces every 20 minutes or so. And so 8 ounces, for a visual, is if you've ever been to a conference, those little cups, I mean, it truly is a cup, right? 8 ounces is a cup, but those little cups for coffee, that's about 8 ounces worth of fluid. So drinking one of those every 20 minutes is the recommendation in extreme heat events. As a workplace, one of the best things that you can do is install a water station that's sanitized every day, if not every more often. And then also creating a workplace of culture and hydration. So that could be setting alarms, enacting a buddy system where you're accountable for another person and say, hey, okay, you're on your break now, you go drink your 8 ounces of water or whatever. And another thing that individuals can do, as a nurse, we like to talk about body fluids. You can monitor your urine. So the darker your urine, the more dehydrated you are. Looking at this diagram on the left, that 4 to 5 areas is the area where you should start thinking, okay, I need to drink water. I should have that 8 ounces now, potentially 16 ounces. Once you get to the 6 to 7, you're severely dehydrated and you need to drink 32 ounces and be more attentive to what's going on in your body. Another way to adapt and to protect yourself on the farm is through body cooling. And so some of this includes loose clothing, wide brim hats, sunscreen, we all the things that we know. Part of the partnership work with MCAP, with the extension program at the University of Minnesota, was creating 2 resources. So one was on extreme heat and one was on air pollution. This was the diagram from extreme heat. And so you'll notice that there's 3 columns based on the level of work. And this is adapted from the US military as well as OSHA. Now, I want to say that work capacity and quantifying work is not easy. And so even though this is it comes from reliable sources, there still needs to be more research into what these concepts actually mean, and then also what's realistic for farmers. So we have easy work, moderate work, hard work, and then on the left side, the rows there, we have 5 different risk categories. And again, thanks to Laura, this is using the wet bulb global temperature index, so not the heat index. So you can kind of go through and see, and again, thinking about that feasibility, I want to look at, say moderate work, but an extreme risk with the WBGT index. So that's extreme risk, 90 degree plus Fahrenheit. So moderate work, that's resting or working 20 minutes, resting 40, and 1 quart of water. And I've, again, presented this before, and Christine has seen me. And the general reaction from the audience is this just isn't possible with farmers. This isn't standardized. OSHA, I believe, is working on some standardizations for outdoor workers, especially farmers and agricultural workers. But these are just recommendations. We understand that the feasibility of this, the workload is just, it's not necessarily possible. But this is what the literature is saying to do. So again, just keeping your mind active and thinking about that. Laura talked about building heat tolerance, so I won't go too much into what that means, but the recommendations for that are following the 20% rule. So increasing workload and heat exposure by 20% over 7 to 14 days has been shown to be the most effective through multiple studies with athletes, with outdoor workers, with the military as well. And so it's important, though, to note that that 20% is either an increase in workload or 20% increase to heat exposure, not both. So that could also increase the amount of time that you're going through this acclimatization process. Also important to note that day 2 can be harder on your body than day 1. We may be familiar with this if any of us work out. Day 2 is usually worse, but also even as you're getting back into the season, that next day is like, oh, I hurt more than I did the day before, or whatever. So keeping in mind those, it's also important to think long term. If your workers, your employees, your farmers end up having heat stroke or some of those heat illnesses, recovery from that can take 2 weeks. So what's more beneficial, doing this 20% rule and slowly building into the season or into a new environment or a new workload, or losing out on that person for 2 weeks? the kind of that risk, risk versus reward there. And so again, workplaces, what they can do is have a heat acclimatization plan. Create this culture that this is important, that your safety is important, and that long-term goal of productivity and safety over demand or any of that. That moves us into air pollution. We've seen in the Midwest, especially this last year, historic levels of poor air quality. And this is important, especially as outdoor workers, because those air pollutants are tiny, PM 2.5. So they're 2.5 micron size, and they have the potential to embed deep into the lungs. And then they stay there or get absorbed into the rest of the body, causing acute and chronic complications, and can also exacerbate pre-existing respiratory diseases. So again, we kind of gathered the data that was available on this and provided some recommendations. This was, again, that work with Extension. These are all the standard air quality index levels. So less than 50, good, so on, over to greater than 200, very unhealthy. And then the recommendations, both for everyone, but also for those that are working outside. Some of the risk factors that we talked about, pre-existing conditions, include asthma, COPD, allergies, cardiovascular diseases. The young, their airways haven't fully developed yet, and the elderly, they get more stagnant and a little more sclerotic is how we call it. And then also the pregnant. So another thing that your farm can do is to look at the airnow.gov. It gives you up-to-date air quality indices, or it gives you up-to-date air quality index. And then also consideration of placing air quality monitors, air pollution monitors on or around your farm. And that just helps to increase the data, because this is aggregated data. So those areas with expansive land that may not have these measures available are just predictions from nearby sensors. So that could be another thing, to have more concrete data of what's going on in your area. Another consideration are masks. So anything rated N, R, or P, and then 95 to 100, so 95 or higher, are appropriate to wear in those poor air quality days. Surgical and cloth masks and bandanas are not appropriate for smoke or any other of the PM 2.5 pollutants. Eye protection, goggles, glasses, sunglasses are recommended by the American Optometric, the AOA, the American Optometric Association. However, there's more research that needs to be put into this to determine the efficacy of protection from PM 2.5. I'm thinking even with glasses, like I still have avenues for smoke to get in. So what's the most effective? And then again, what's the most realistic? Looking at activity and workload, limiting those outdoor activities, especially strenuous work. If it's inevitable, making sure that you have mask, eye protection, and you're providing proper breaks. And then hydration. So air pollution dries out those essential respiratory pathways, affecting the normal functioning, which allows those particles to travel deeper into the lungs, thus causing those acute and chronic problems that we talked about. And then the last thing that I'll say is air filters. And so during those times of rest, or if you're staying indoors, make sure that the place that you are in, the room that you're in or whatever, is completely enclosed. And then you can also run air filters within that, because even opening the doors, opening windows, things like that, momentarily allow those particles to come into the room. And then we have our HVAC systems that pull air from outside and such. So having MERV 13 plus filters, which is just the filter classification, Corsi-Rosenthal filters, I have resources available on those, or HEPA filters are all effective ways to help purify that air indoors. And lastly, I want to talk about a topic that's often not talked about, or not talked about enough, and especially with farmers, and that's mental health. So heat, air pollution, environmental degradation, all the things that we are seeing and are projected to see more of, take a toll, especially on those of you that are working out in the land. Your livelihoods depend on it. Your history, your family ties are to the land. You've seen it as it once was, and it's changing. So 7 in 10 Americans are concerned about global warming. About a quarter of those are very worried about climate change, and 1 in 10 are on edge or anxious about global warming several times a day. So this is a problem that all of us are experiencing, and it's okay to talk about. And in fact, it needs to be talked about. The risks as it applies to farmers, you all have one of the most demanding jobs available. There's high financial stress with sometimes low income and revenue. You have a dependence on the environment and that predictability that is changing. You have long hours, it's manual labor. Again, you've had that sense of what the land once was and is no longer. That's called solastalgia. It's a socially isolating profession. We've talked about the aging population. This is both, nationally, globally, but also in South Dakota. There's historical inequities within agriculture. We talked about the accessibility to healthcare services, and then there's higher rates of suicide. So farmers are 2 to 5 times, or have suicide rates 2 to 5 times higher than the national average. There's increased levels of anxiety and depression. But you all also have strengths, and one of those strengths is with the organic farmers. You have a perception of doing well for the environment, you have doing well for the sellers, for yourselves, and you have an increased connection with those consumers and the community through CSAs, through farmers markets. And this isn't specific, I mean, this stat is specific to organic farmers, but the rest of you may also feel this way if you partake in some of those community activities. So it's important for farmers, for those, whether you're, on your farm, in your community garden, like Christine was mentioning, to recognize the signs of stress, of mental well-being, or the mental health issues. So a change in routine or social activities, a decline in the care of domestic animals, increase in accidents on the farm, the decline in the physical appearance of the farm, and then decrease in interest in those events and activities. So again, those farmers markets, those CSAs, even just, maybe you met with this person, your routine was to meet at the local wherever, and they're no longer showing up. So checking in on people and making sure that it's a safe environment to share these struggles, because they're very real struggles. And then lastly, there are other opportunities to speak with individuals, and this is Minnesota's NAMI, but there is a NAMI, so it's the National Alliance of Mental Illness. There is a NAMI for each state, so there is one for South Dakota. These are some of the projects that were done in Minnesota. Maybe they can be adapted to South Dakota. Maybe there are already projects going on there. But regardless, is to know that you're not alone. And then there's an increase in telehealth as well. And I know that there are issues with broadband and that, but know that there's availability. And as health professionals, again, I'm kind of the oddball in these conversations, but we want to hear from you. And I'm working with a couple groups that we want to hear from farmers. What are your concerns? What do you need from us? What do you want to see in the research? And then also, what's feasible? Like, again, we can give you these recommendations, but are you going to use it? Is it possible? Are there, how can we adapt this to best suit you in the actual practice of farming? I additionally have some resources here. I'll share this PowerPoint with Christine and she can share it with all of you. I know there's the recording of this, so feel free to use any of these as you wish. And that's it. And feel free to contact me as well as you see fit.
Well, thank you, Kent. I really appreciate it. I'll open up the floor if there are any questions from our audience. I do want to highlight you mentioned South Dakota resources for mental health. We do have an SDSU Extension mental health specialist, Andrea Bjornstead, and I dropped a link to one of her articles titled "It's Okay to Not Be Okay," specific for farm stress assistance. So Kent, I really appreciate how tackled heat and air pollution and the mental stress that folks are under. I continue to spend a lot of time thinking about how much water I'm going to make my team drink this summer. And they don't know it yet, but they're all going to be watching this recording as part of a team training. And I do see we have a question from an audience member. Someone is a little bit confused when it comes to air pollution, that they don't recognize the filter grading that you were referring to. Can you expand on all the air filter systems? And I'm thinking they might mean for indoor air, but if you can maybe clarify for masks or respirators as well.
Yeah, I kind of got the hint that it was for the mask, but I'll do both.
Oh,
to the best
okay.
that
Maybe I
can.
missed. Okay.
No, maybe not. So the NR or P. So an N95, that's similar to what a lot of people were wearing during COVID. Those are the N95 respirators. 3M makes them. There's also the KN95, which are out of the Eastern globe. So N is not oil resistant, R is oil resistant, and P is partially oil resistant, if I'm not mistaken. So that's the only difference of those. So it really depends on the environment that you're in. An N95, if you're out in the field, would be perfectly fine. If you're a mechanic or something like that, where you're exposed to more of those oils, then you might want an R or a P or paint, those types of things where you could get chemicals also on your mask. That's where the R and P come into play. The 95 to 100 are the percent for filtration of the PM 2.5 particles. So no matter what, 95 through 100 are all appropriate for PM 2.5 particles as it relates to outdoor work. 100 just being, that's going to block out more percentage of that, so 100%. The air filters indoors, so MERV 13 plus, like I was saying, that's just the standard categorization of air filters. So it's MERV 1 through, I think, 15. And so we're looking at those 13 to 15 are just going to be able to filter out those smaller particles. So that's what that is. The Corsi-Rosenthal, I believe it's in the resources as well, but it's a box. So you make a box out of those MERV 13 plus filters, and then you attach a box fan to whatever side is open. So it's three, or what would that be? Five sides of a cube, and then the sixth side is air fan, a box fan. And so that, because it's pulling the air in through the one side, the 5 filters, purifies the air and then puts out purified air. So the Corsi-Rosenthal, there's been it's a relatively new concept. There's been some research that shows that it's actually more effective than HEPA filters. And MERV, just having a MERV 13 plus air filter in your system is good, but that's probably the least effective. So in some instances, it's MERV, HEPA, Corsi-Rosenthal. In others, it's MERV, Corsi-Rosenthal, HEPA. But no matter what, Corsi-Rosenthal and HEPA are probably your better options of filtering the air. And Corsi-Rosenthals tend to be a little bit cheaper as well. So that's another option if it's not a place that routinely needs air filtration. And I think that would answer that question. And Christine, I did want to add to, in my resources, I did put the 2 South Dakota State Extension mental health resources that you actually added to the chat. So I did find those and put those in there.
Awesome. Well, as always, I'm learning new things. And Kent, I do have kind of a tricky question, maybe to wrap us up. I always like to end with a zinger. Some of our fruit and vegetable and cut flower farmers who are listening to this might be in some pretty geographically isolated pockets of South Dakota. So as we think about those 911 heat stroke situations, where it may take 30 to 45 to, oh, heaven forbid, an hour for an ambulance to reach that person, what advice do you have, or extra preventative advice do you have for folks who are in that situation where, oh no, because that slide where it's like minutes, that's very scary to me.
Yeah, no, and it is a really scary situation. And again, yeah, that's something that as health professionals we're mindful of. And again, part of the groups that I'm working with are how can we best suit you all. I work with Resilience Hubs is also trying to tackle that in greater Minnesota. But to really answer your question, it's putting the work in towards prevention and protection and not waiting till we get to the point of heat stroke. So if you start enacting some of those um, um, activities of whether it's setting alarms for your workers that it's time to hydrate, wearing the loose fitting clothing. I know a lot of these things are common sense, but as we're out in the field working, we forget about a lot of these things. So having that accountability, whether it's a workplace culture or a buddy system, can really be beneficial. Now, if it gets to the point where you are in heat stroke, again, call 911. No matter how long it's going to take, call 911. But that's where getting that person into the shade, getting their feet elevated, if you know that you're far away from, or that it may take a while for EMS to get to you, or for your whoever it is to get to a hospital, then I would strongly consider having ice baths in proximity to wherever it is you're working in the field that day, because that's going to be the best thing to bring that body temperature down. And that's where it's, most significant, because it's once that body temperature gets to 106 is when that organ failure kicks in. And 103 is not great either. It's not a maintained type of thing, but if you can bring that body temperature down, that's going to be the most effective if the wait time is a bit longer.
Mm, excellent. That's really helpful to think about and to again be proactive. So I know tonight's topic was a lot of maybe some doom and gloom, but again, I think Kent, you gave us a lot of tools to really to mitigate these issues and be preventative and train ourselves and train our teams. So I really, really appreciate that. Any parting words of wisdom from you that you'd like to share with the South Dakota crew?
Um, I think so. I'm appreciative that you hold space for me to come into these areas and talk to you and talk to the farmers in South Dakota and across the nation. More than anything, I know, like I said, a lot of these are either common sense or I don't know that I can really enact that. So, but more than anything, it gets us thinking about these are issues, especially with farmers. I feel like the notion is, you know, crop yields, the people that I'm giving my food to, you all care a lot about the other end of it, and in doing so sometimes neglect yourself, but you are equally as important. And so just thinking about what this means to you as well, and we need you to be healthy so that we can be healthy. So keep doing what you're doing, take care of yourselves, and talk to us. We want to be able to help you be the healthiest that you can be as well.
Well, Kent, what a wonderful way to wrap up this session. And honestly, what a wonderful way to wrap up the entire series. I'll just echo that, part of my sentiment with doing this series was really, out of care and out of hearing questions from people who were interested in some of these topics. So do take care of yourself and do, have a safe and successful season, because that's what we always want for you from our extension and our university lens. So with that, thank you so much, Kent. Thank you so much, audience. Thanks to the folks who are watching it online after the fact. Never hesitate to reach out. We love hearing from you. And as always, watch the SDSU Extension website for future events, whether they're virtual or in person. We certainly have a summer full of fun on-farm field days coming up. So watch your email inboxes and the website for more information about that in the future. Have a great night, everyone. And thank you so much for talking about safety with us.